Okay, we have P4, and P4 we're going to do over the next 3 days, 3 lessons. So this is just the first day of P4. You do need to make sure you go through P4 and know the vocabulary, even though you don't have a printed out note packet of what the vocabulary is. You're really going to want to make sure you know what those are. So when I say an extraneous root, you know what it is that I'm talking about. So the first thing we want to do in today is determine if something is a solution. If it's going to be a solution, I can substitute it in the value and simplify. If it works out that the left side equals the right side, then yes, it's a solution. If the left side does not equal the right side, no, it's not a solution. So first thing we need to do is, given some equation, be able to substitute and come up with, is that an actual solution or not a solution to the equation that you're being asked to find. So let's look at a couple of examples. The first example, 5 over 2x minus 4 over x is 3. Is x equals 4 a solution? So we're going to substitute and get 2 times 4 minus 4 over 4. So we're going to get 5/8 minus 1. 5/8 minus 1 is going to give us a negative 3/8, and that is not true. That does not work. All right, let's try a different one. Let's go 0 equals 12 minus 4x, where x is 3. So we're going to get 0 is 12 minus 4 times 3. 0 is 12 minus 12, so 0 is 0. Yes. Determine if something's a solution. Substitute. Either the left equals the right or it doesn't. Yes solution, no solution. All right, the next two things are part of your vocabulary that you should be responsible for, and that's the identity or the conditional equations. So if you have 2x minus 1 equals 2x minus 2, and distribute 2x minus 2 equals 2x minus 2, they are the same. Therefore, it is an identity equation. If I have 5 over x plus 3 over x is 24, this is going to actually come out to anything different. There's no way that this can be 24 value because I would be solving for x. So therefore, this value cannot be x on the left-hand side. It's conditional. A conditional means you are solving for something. You are finding a value of something. In order for this to become 24, it's on the condition that x is going to be a certain value. Once we know what that x of a certain value is, okay, then we can make one side equal the other side. But until we know that x conditional value, we can't do that. So it is a conditional sentence or equation. All right, you're going to be asked to solve fractional equations. Fractional, also known as rational. These two words interchangeable. Make sure you know them as that. But in order to do that, you do have to find the least common denominator. LCD shorthand. We should be a little bit familiar with that. So let's look at a couple of examples for solving a rational equation. The first one, x over 5 minus x over 2 equals 3. The LCD, the least common denominator that we're going to find, is going to be 10, because 5 and 2 are the denominators, so that's the D part. So what's least common between 5 and 2? 10. That means we're going to multiply everything by 10, including the other side. We tend to forget this one. Don't forget this side. The reason we do that is because it's going to reduce out our fractions, because when we multiply by its commonality, it gets to reduce. And then multiply what's left standing. So there's 2x minus 5x is 30. So negative 3x is 30. X is negative 10. When you are dealing with rational equations, you need to check to make sure that the answer is plausible. Now, the only way it wouldn't be plausible is if we have a variable in the denominator. We don't care about numerator. Denominator. Since both of these are numbers, we're going to assume this number is actually correct with our mathematical skills. But on the next one, we're going to have to check a little bit farther. So here we have 17 plus y over y plus 32 plus y over y is 100. So the common denominator of everything is y. I'm going to multiply y to everything. This will reduce out. This will reduce out. So I get 17 plus y plus 32 plus y is 100y. Now when I go through my solving process here, 17, 32, we get 49. Move over the 2 y's, so we're going to get 98y. So y is 1/2 when I divide the 49 by the 98. Now, if I look up here, there's a letter variable in my denominator. If I put 1/2 into this denominator, is that going to be valid? And the answer is yes, because the only thing that's not valid is a 0 in the denominator, of which we're going to look at a little bit more tomorrow and so on, but that's the extraneous root. That's part of your vocabulary. So let's look at one more example. 1 over x minus 2, 3 over x plus 3, 4 over x squared plus x minus 6. If I look at these denominators, and I have to look at them as all or none, they're all connected. Plus minuses you can't separate. So x minus 2 is all together, x plus 3 is all together, and then the x squared plus x minus 6 is together. But I should recognize that this x squared minus x minus 6 is really the other two in factored form. So when I look at all my pieces, the common denominator is both pieces. So that's what I'm going to multiply to all components, because that is the common denominator, those two factors. Now, when I do this, the x minus 2 will cancel the x minus 2, leaving 1 times x plus 3. The x plus 3 will cancel the x plus 3, leaving 3x minus 6, because we have to distribute. And over here, the x minus 2, x plus 3 all cancels out, and it just leaves 4. So when I solve this one, now I'm going to get 4x minus 3 is 4, 4x is 7, x is 7/4. All I have to do is check. If I put 7/4 in my denominator, up here, 7/4, do I get 0? No, so I'm okay. Do I get 0 by putting 7/4? No. Well, if I didn't get it in either one of those, I'm not going to get it over here. So 7/4 is my final and complete answer. And that's going to be day 1 of P4.